Good morning, students. Welcome to the next lecture of electronic measurements and instrumentation. In the previous class, we have seen how the dual beam CRO is there. So, what is the block diagram of dual beam CRO? That concept we have discussed. In this class, we will see dual trace CRO. In this class, we will see the concept of dual trace CRO. So, for the dual trace CRO, we have two channels, that is channel A, channel B. So, channel A is the first one and channel B is the second one. Two signals we are applying at the input of this dual trace CRO. For the first channel, we have preamplifier and attenuator. For second channel, we have a preamplifier and attenuator. Both has delay lines. Here we have first delay line. Here we have second delay line. First delay line, second delay line. Here, the first delay line is connected to the electron switch directly and vertical amplifier and vertical deflection plates. So, this is the first channel path. The second channel path, see here, the second channel path has preamplifier attenuator, delay line, and here we have a selection switch. Here we have a selection switch. With this switch, whenever you require this channel to information, the channel information is connected to this electronic switch, and this information will be displayed, amplified at the vertical amplifier, and finally it is displayed at the vertical deflection plates. So that is about the channel 2. Right. From the channel 1 and the channel 2, after preamplifier and attenuator stage, the signal is received by this trigger circuit, that is the horizontal deflection system circuit. The first block of horizontal deflection system circuit is trigger circuit, next sweep generator, next horizontal amplifier, where channel A, channel B informations, that are the internal signals and external triggering circuit and line. These four informations are connected to this trigger circuit. These four informations can be connected any one of the signal to the trigger circuit based on the switch position. Here, whatever the switch here we are using. Consider this is the first switch. The switch 1, S1. So when the S1 is connected to A, channel A information, based on the channel A information, the time information will be retrieved at that horizontal deflection system. If you are connecting channel B, the channel B related horizontal deflection system is working based on the channel B information and external signal. These are connected in some other cases. Presently we are connecting either channel A, channel B, that is dual trace CRO. Okay, in the dual trace CRO, we are taking a channel A, channel B information. So, leave the external line information. So, this trigger switch connects either channel A, channel B information, and this information is connected to sweep generator circuit, and this output is connected to the horizontal amplifier. So, for the sweep generator to horizontal amplifier, we have a special switch is there. This switch is connected to either is connected to the electronic switch, where it will be connected to either channel A information or channel B information. Other than this, we have an XY mode, where this XY mode is useful to see the signal. That means you can see the channel A information in the X direction, channel B information in the Y direction. That is amplitude or amplitudes of the channel A information you can see in X-axis direction, and channel B information you can see in the Y-axis direction. That is, there is no time-based generator information here. Channel A and channel B informations are connected in the XY mode. In the screen you can see both signals amplitudes only. There is no time period at that place. Okay, so in the X direction one amplifier, Y direction another amplifier. That is, the channel B is connected to this horizontal amplifier, that is in the X direction. So this is the Y direction signal, this is the X direction signal. So that is the special mode, XY mode. So presently this is not necessary for us. When we are doing the less joyous measurements, then we are using XY mode. Okay, presently there is no necessity of this XY mode in this concept, that we will discuss later. Okay. Finally, see here, we have two channels of informations, but here we have only one vertical deflection plate. Here we have only one vertical deflection plate and one horizontal deflection plate. Only one set of horizontal deflection plates, one set of vertical deflection plates are there in the dual trace CRO. In the dual beam CRO, we have two vertical deflection plate systems and one horizontal deflection plate systems. But in the dual trace CRO, only one vertical deflection plate system and one set of horizontal deflection plates are available. So this is a block diagram description of dual trace CRO. So you have to keep this picture in your mind, then listen next points. The CRO has a single electron gun, that is dual trace CRO has single electron gun whose electron beam is split into two by an electronic switch. This electronic beam is splitted into two parts of the signals, where one part is related to channel A and another part is related to channel B information by a special switch called electronic switch. By a special switch of electronic switch. Okay, so this is that particular electronic switch. This is special type of electronic switch will help to see the two signals. There is one control signal for focus and another control signal for intensity. Here we have two control signals. One is for focus and one is for intensity. Where focus and intensity signals will give the display, better display. Two signals are displayed simultaneously. So here two signals are displaying simultaneously. The signals pass through identical vertical channels are vertical amplifier. So here we have two identical vertical channels and two vertical amplifiers. Those we can see. Each channel has its own calibrated input attenuator. So it has own calibrators and attenuator circuits and positioning control. That means two signals has two different position controls, two different attenuators, so that the amplitude of the signal can be independently adjusted. So there is no necessity of depending one channel amplitude to another channel amplitude. Channel 1 amplitude you can adjust separately, channel 2 amplitude you can adjust separately. There is no necessity of depending on each other. Both are independently working and we can adjust the amplitudes are independently. It's not a big problem. Next. A mode control switch enables the electronic switch to operate in two modes, that is alternate mode and Char mode. Here we have two types of modes. One is alternate mode, second one Char mode. First we will see alternate mode. This is the alternate mode. When the switch is in alternate position, when the special switch is in alternate position, the electronic switch feeds each signal alternatively to the vertical amplifier. So for the same vertical amplifier, the information, channel 1 information and channel 2 informations are feeding alternatively. For some time channel 1 information, for some time channel 2 information, it is feeding. That is alternate mode. So the electronic switch alternatively connects to the main vertical amplifier to channels A and channel B and adds a different DC component to each signal. The DC component directs the beam alternatively to the upper and lower half of the screen. The switching takes place at the start of each new sweep of the sweep generator. That we will see graphically clearly. The switching rate of the electronic switch is synchronized to the sweep rate. This is very important. The electronic switching speed is synchronized with the sweep rate. It is synchronized with the sweep rate, so that CRT spot traces the channel A signal on one sweep and channel B signal on the succeeding sweep. So see here, we will see the graph with a sweep generator. So here, this is a sweep signal. So this is the sweep signal. This is a charging period. Next, this is retrace and This is the charging period, this is the retrace period and hold time, and this is again charging period. So from here to here, this is the one sweep period. So after one sweep period, this is the second period and this is the third period. Okay, in the first period, in this first period, channel A information is going to be displayed here. In the second sweep period, channel B information is going to display here. Here channel A information, here channel B information. In the third sweep period, again channel 1 information. In the fourth sweep period, again we can see channel B information. Here channel A, here channel B. Right? So alternatively you are getting the channel A information, channel B information. Channel A information first you are getting in the first sweep period. In the second sweep period you are getting channel B. In the third sweep period you are getting channel A. In the fourth sweep period you are getting channel B. So what happened with the channel A, channel B informations? So see here, whenever the channel A information is presenting, at that time the intensity of the channel B is going to display off. When channel B is going to present at the output, then channel A intensity is going to off. When channel A is going to display, channel B intensity is going to off. Like that, it will display only one signal at a time, but it will produce the signals alternatively. For one period, one channel information, another sweep period, another channel of information, it is going to display. So this is the alternative mode. So the time relation, this is the graph which representing time relation of a dual channel vertical amplifier in alternate mode. In alternate mode. Next, see Char mode. When the switch is in the Char mode, when the switch is in the Char mode, when the switch is in the Char, I said that electronic switch in the two modes. One is alternate mode, second one is Char mode. Alternate mode we have completed. Now we will discuss the Char mode. In the Char mode position, the electronic switch is free running at the rate of 100 to 500 kilohertz, entirely independent of the frequency of sweep generator. So here in this Char mode period, the oscillator is running with 100 to 500 kilohertz of speed, entirely independent of frequency of sweep generator. It is not depends upon the sweep generator frequency. It is completely independent of the electronic switch. The switch successively connects small segments of A and B waveforms. So in the alternative mode, for 100 milliseconds channel A, 100 milliseconds channel B, or 100 microseconds channel A, 50 microseconds channel B, it is connected in that fashion. But here, it is connected for a small segments. With compared to that, it connects with a small segment because of it is running with very high frequency. Okay, channel A and channel B waveforms to main vertical amplifier and associated. The switch successively connects. The switch successively connects small segments of channel A, channel B waveforms to the main vertical amplifier at a relatively fast chopping rate of 500 kilohertz. So it is connecting the electronic switch is connecting to channel A and channel B information with a speed of 500 kilohertz. For example, 1 millisecond segment of waveform are fed to the CRT display. That means 1 millisecond of period only, 1 milliseconds time period of information only connects channel A information. Second millisecond channel B. First millisecond, third millisecond channel A. Next again fourth milliseconds channel B information. So see here, the time relation of dual channel vertical amplifier in the Char mode. So this is the sweep signal. This is the sweep signal. In the sweep signal, see here, this is the sweep signal. So this is the first time period, this is the second time period, this is the third time period. But the sweep period is independent of this channel A, channel B information. So see here. So this is the the upper peak is representing channel A information, the down peak is representing channel B information. This is channel A, this is channel B, channel A, channel B. So the upper portion is representing channel A information, the downer portion is representing channel B. That means one voltage level is high and another voltage level is less if you have two signals of information in a system. So the two signals has maybe same information, or one is high, one is low. Here I am representing channel A is high and channel B is less. So coming to here, when the chop signal is connected here, so here channel B information, it is representing channel A and channel B information. So this is channel A and this is channel B, channel A, channel B, channel A, channel B, channel A, channel B, channel A, channel B. So here it is representing two channels of information separately. In between, actually this straight line has no value, so it is nothing but as blanking pulse. This is called blanking pulse. So here in this we are calling this is sharp transient blanking pulses. So whenever the intensity is available, it will displace channel A, channel B information for a small segments. In between the segments you can see sharp transient blanking pulses, but it doesn't has any value. If the intensity is off, no signal is displaying here. If the signal intensity is very high, it seems to be like as a continuous waveform. That means we have a pulse signal. If the moderate intensity light is available, then it will shows the sharp transient blanking pulses in this waveform. So this is the chop mode. This is the chop mode. In the dual trace CRO, we have two types of modes for the electronic switch. The electronic switch has alternate mode, chop mode. Alternate mode we have seen just now in the previous slide. This is a alternate mode and this is a chop mode. In the alternate mode, based on the sweep period, the signal is varying here. Here it is free running with the sweep generator. So there is no necessity of depending on the sweep generator. It is based on the free running oscillator, that is 500 kHz and 100 kHz. Based on that it is working. For the small segment of portions, the signal will be displayed here. If the chopping rate is slow, the continuity of the display is lost and it is better to use alternate mode in the operation. If the chop rate is very slow, there is no necessity of using the chop mode. You can go with the alternate mode, because of at that time the signal is not going to be displayed on the CRT screen. In the added mode, that is we have a special mode called added mode. That is channel A, channel B. We can add both our signals and you can see a single waveform. That is a special mode in the chop mode. In the added mode, the operation of a single image can be displayed by the addition of signal from the channel A and channel B. So channel A and channel B information, both informations are adding. If the channel A is consisting of 3 volts, channel B is consisting of 2 volts, 3 volts plus 2 volts, 5 volts. It will show finally 5 volts of information. That is the add mode, that is a special mode. Okay, both signals can be added together and it will display A plus B information. In the XY mode operation, the sweep generator is disconnected and channel B is connected to the horizontal amplifier. So in the special mode, this is called XY mode. Okay, here these modes are very, very important. When you are operating a CRO, you can see these modes easily. In the XY mode, the operation, the sweep generator, what it does, the sweep generator will be connected to the time-based generator and this time-based generator is connected to the second channel information. In the X direction, you can see the second channel amplitude information. Since both preamplifiers are identical and have the same delay time, accurate XY measurements can be made. So both channels has some delay time, same delay time. So you can measure X direction one channel information, in Y direction another channel information. You can see parallelly. So this is about dual trace CRO, right? This is about dual trace CRO. Now we have completed the concepts of dual beam CRO in the last video lecture. In this lecture, we have completed dual trace CRO. Now we will take the comparison between dual beam CRO and dual trace CRO, right? So these are the differences between dual beam and dual trace CRO. So the first part of here we are representing with the dual trace CRO, and the second part we are representing with the dual beam CRO. Okay, so here see one by one the points. The first point here we are written one electron beam used to generate two traces. Two electron beams are used to generate two traces. In the dual trace CRO, only one electron gun is available, and within the one electron gun we can see two channels of information. But in the dual beam CRO, we have two electron beams to see two signals. Okay, in the dual trace CRO, only one vertical amplifier we are using, but in the dual beam CRO, we are using two vertical amplifiers. Okay, as per our previous discussion, this is the second difference. The third one, the two signals are not displayed simultaneously in real time, but appears to be displayed simultaneously. Actually, in the real time, two signals are not displayed at a time, but here it seems to be like as two signals are representing simultaneously, but in real time it's not like that. Two separate beams are used. Hands with you, just switch the traces. You can see both switches in the real time, what happened in the real time. So it's not big problem. Just switch the channel 1 to channel 2. Okay, otherwise you can see in the dual mode of operation also. As two signals are displayed separately, the signals may have different frequencies. So when you are seeing the two signals has different frequency in the dual trace CRO. For channel A different frequency, for channel B different frequency. Whether coming to that in the dual beam CRO, both signals has to be same frequency, otherwise it's not ready to display the signal. The two channels of information has both same signal, same frequency. Next, the size and weight is less because of less hardware using, single electron gun we are using, so for that reason the weight and size of the dual trace CRO is less. Where the dual beam CRO, here this is dual beam CRO, dual beam CRO is very high in weight, right? Size also very high, very huge amount of size is there with compared to the dual CRO. The dual beam CRO is very heavy weight. Next, cannot be operated as fast speed, hence two separate transient signals cannot be grabbed. We cannot operate with very fast because of two signals work is doing under an single electron gun. Here we have two separate systems, so we can do with very high speed computations. With very high speed computations we can do. Why? Because both has same time-based generators. So these signals we can see with very fastly. Next, the cost is less due to single electron beam. The cost is very high due to two beams in the dual beam CRO. It's a general structure. With a single electron gun, it will require less power. Only if you are using only one electron gun, it will consume very less power, less cost, less in size. When you are using two electron beams, it is very cost in high, very high weight is also very high, and power consumption is also very high. Power dissipation is also very high for dual beam CRO. Next, two different modes of operation are alternate and Char mode. Here we have two different modes of operation. One is Char mode and one is an alternate mode. Here two different types of are using double guns to split beam using single electron beam. Here we have channel A, channel B independent modes, or dual modes, or X5 mode. These modes are available in the dual beam CRO. Okay, these are the differences in the dual beam and dual trace CRO. Just note it down. Okay, so these are the major differences. Take the video, pause, and and note it down the differences. So these are the differences between dual trace CRO. So the left side part is consisting of dual trace CRO and the right side part is dual beam CRO. Okay, thank you.